So in this hopefully short video, I'm going to explain how I would do these vector questions. Now, as I have said, vectors is one of those very isolated topics in which we don't really use much calculator. We can use a little bit of it to do things such as dot product, but it's actually quicker to do a lot of the time by hand anyway. So in this example here, it says that the magnitude of A is 2 times the magnitude of B, which of course means that it's twice the length. But which of the following statements is true? These are the ones which take the longest because a lot of the time you have to work your way through them. It's just whether you work your way up or down and work out one of them's false, or work your way down like so. Now, first of all, let's have a look. You just have to eliminate. Vector A is equal to 2B. How the hell could those vectors be parallel is basically what we're saying, because of course one would be a scalar, one is a scalar multiple of the other. So that is complete nonsense. Let's have a look at this one though. Let's have a look at vector A. To get from vector A, I can get the vector B from the other side and put it on the other side. That is minus vector B is equal, plus vector C plus vector D. Now, is that true? Well, vector A, to get from vector A is the same as going positive D. I don't know about that. Maybe it is E. Okay. B minus D is 0. Well, that can't be right, because isn't vector B plus D equal to 0? Because they're the same vector, just opposite in opposite directions. Okay, so same magnitude, opposite directions. So B plus D is equal to 0. So therefore that is incorrect. A plus C is equal to 0. Is that true? A plus C is equal to 0. Absolutely. Yeah? So that is my answer. Now, Riley, you said that one was true. I guess what I would do is I would check that A is equal to B plus C minus D. Well, is that true? Well, yes, the B is correct. The C is correct. But it's actually, if that was a plus D, that would be correct. Okay? So they do some sneaky things. So the answer is D, yes. Unit vector perpendicular to 5i plus j minus 2k. Well, let's find our unit vector. Our unit vector is obviously 5i plus j minus 2k. And our magnitude of that is square root of 30. Now, if I have a unit vector perpendicular to something, then that means the dot product would be 0. Let's have a look at, if I was to dot product 5 times 5 would be 25. So I would do that. Now, first of all, that one's not going to give me a unit vector anyway. So we can clearly get rid of this. Is this a unit vector? B? No, so we could clearly get rid of this. As it turns out, we've got 1, 2, and remember that a unit vector perpendicular to means that it has a dot product with this would be 0. So we can say that 2 times 5, and minus 4 times 1, and 3 times minus 2 is going to be 10, minus 10. So that's going to be 0. So that is perpendicular. What about this one? This is probably to throw you off. Is that perpendicular? No, it's not. So we know it's one of two things. It's C or D. Which one is it though? D. It has to be D, because D is the only unit vector there, isn't it? Okay, so a bit of a trick one in that one. this one's really straightforward. We know that the angle cos theta is equal to u dot v over magnitude of u, magnitude of v. Okay, which is equal to u dot v is 1 plus 2. Be careful, make sure this one doesn't have a k component. So, and magnitude of u is root 2, the magnitude of the other one, so it's 3 root 2, which is equal to 3 over 3 root 2. Cos theta is 1 on root 2, so theta must be equal to 45 degrees. Pretty straightforward stuff, isn't it? If you're using a calculator for that one, you... Now, this one is a little bit... This one's, you know, a bit more confusing. Shh. But I guess if you wanted to rearrange that, you could in your CAS calculator. We've got 3x plus 2y was equal to 1, wasn't it? So we could go to menu 3.1 and go solve. And we can say that 3x, we want to solve 3x plus 2y is equal to 1. Is equal to negative 1. Thank you. That's going to save me a lot of trouble because otherwise I would have got something stupid. And that is going to give me that. Now, of course, you don't have to write this on your exam, but we've got a gradient of what? Minus 3 on 2. So we've got a gradient of minus 3 on 2. Now, what does that mean? It means that if we're trying to find a vector perpendicular, then the perpendicular gradient is going to be equal to what? 2 on 3. Now, if you think about that, that's the same as rise and run. Would you agree? Now, our rise would be considered the y component or j component, and the run would be the x component or I component. So, make sense? I hope so.
I got... Oh, me and Alex got... No. We got D. I got A.
The answer's A.
Oh, damn.
I'm telling you, the answer's A. All right, force of magnitude 18 newtons. Now, acts on a body at an angle of 150 degrees in the anti-clockwise direction. So let's draw a diagram quickly. This is what we're looking at. And we're looking at 18. How would we represent that as a vector? Well, first of all, this might be one of those ones where you want to rule out 2 or 3 things instantly. We can say that, have a look at the I component is going to be negative and the j component is going to be positive. So automatically I can rule out those 2. I can also rule out A. So can you see there, just by having a visual representation of what it looks like, you can see that even if you had to guess this one because you couldn't work out one or the other, you've got a 1 in 2 chance of guessing it right. But as it turns out, we know that this vector here, the component of this vector here, just using basic trigonometry, that's 30. We know that that angle's 30 degrees and I've got 18. So if I was to split the vector up into a perpendicular and a parallel component, then I'm going to say that we've got this green vector here is going to be 18 sine 30 degrees. And that, is, of course, is my j component. And my I component is going to be, well, it's negative 18 cos 30 degrees. That's going to be my I component. So, therefore, 18 cos 30 is going to be 18 root 3 on 2, 9 root 3, and the I component, the j component is 9. Beautiful. The answer's C. Angle between these vectors. Well, first of all, I'm going to go straight to cos theta. Cos theta is equal to, well, I'm going to get the dot product, which is equal to 2 minus 4 over the magnitude of A and magnitude of B. That's 3 times 3, which is 9. Now, cos theta is equal to minus 4 on 9. Now let's think about just quickly, what would be the rule for the second quadrant? I've got theta here. What goes in here? Pi minus theta. What was this one over here? The third quadrant is pi plus theta. And that is 2 pi minus theta. So, how would I work out theta? Theta is equal to the inverse cos of minus 4 on 9. Now, have a look up here. I can't see anything like that. This certainly is not the same. That's not the same. What the hell is that? Pi plus this. What the hell is that? Okay. I would say that I'm looking at, the answer is D.
Good work, Andy.
Scalar resolute of v in the direction of u. Isn't that v dot u hat? Is that the scalar resolute? Yeah. So that is the scalar resolute. Remember that the vector resolute is equal to v dot u hat. U hat. Excellent. So v dot u hat, well, we needed to, of v in the direction of u is 1. So, we know that we've got 2 alpha minus 2 plus 2 over u hat. 3 is equal to 1. In other words, 2 alpha over 3 is equal to 1. So therefore alpha is equal to 3 on 2. Alright, we're flying through these, aren't we? Are these vector ones really that hard, multiple choice? No, they're not that bad. If they're perpendicular, then, well, let's have a look. If they're perpendicular, then you could say that the dot product's 0, which means that m squared plus 4m minus 12 is equal to 0. Therefore, we can solve that, can't we? What are we looking at? We're looking at 6 and 2. So we've got m plus 6. M minus 2 is equal to 0. If we factorise, m is equal to negative 6 and positive 2. Yeah? Pretty straightforward, isn't it? It's not taking us very long. Now, we went through collinearity, so I'm going to pause this here because I really, in particular, want you guys to have a bit of a think about this one. Collinearity. Shh. All right, so this question here, we can see that we've set it up, but my shortcut to collinearity, which you should have in your books, we agreed that if those were 3 position vectors, that it would have to add to 1, so that could eliminate those 3 options. And I've just shown you there, rearrange those vectors. And that one's taken us probably a bit longer than a minute and a half, and the answer's A. Now, as it turns out, there's only a few more that we need to go through. I'll go through those at another stage. I'll stop there.